We are moving to data visualization. What is data visualization? Why do we need to learn about data visualization?
Whatever data is provided or we have gathered, it should when it is presented in some pictures or graphs, it makes more understanding is more easier, sir.
Correct. Understanding is more easy when you present it in the graphical format. Okay.
Yes. Yes.
So see, the purpose here, of course, is to program. We need to learn to program how to create such graphs. Okay.
Yes.
But more important than that, okay, from machine learning perspective, we need to understand what kind of graph is more relevant, when to present what kind of graph. Okay, so we'll slowly get into it. So what does this tell you? When you look at this graph, what does it tell you? See, it has no description. It just has graph. Can you write a couple of lines about it? Or maybe a page about it? What does it tell you? Tell me.
Like in the particular 2014 year, the topics discussed by America were just given in graph format, sir. The most discussed topic is regarding Ferguson grand jury.
Right. So if you see, you know the source also. What is the source of this data? What is the source? Twitter.
Yeah, yes, sir.
Right? And Twitter mentioned means at the rate. Right? So totally just in America, okay, this is only about US. In US, they had 184.5 million tweets. Okay. Totally they had 184.5 tweets. And what they have done is they have created a graph of how many of those things were mentioned. So if you clearly see, as you said, Ferguson grand jury was the most talked about. Okay, then you have election day, Ferguson shooting, State of Union. These are the topics that were most discussed. So you can say that these are the top topic which Americans were interested to know in 2014. Right? No text, nothing. Just one graph with one small headline can give you so much of information. In fact, if somebody starts writing it, right, one, it will be lengthy. Second, when you read it, it may not give the same meaning. The way you read and I read will be different. You might get confused. But when you give the visualization or when you give the chart, there is no chance of getting confused, right?
Yes.
So that's the importance, okay? And some of the features when you are talking about visualization is you have to show the data, okay? Induce the viewer to think about the substance rather than color aisa kyun hai, why the heading is not proper. See, when you show this graph, your focus should go into the content, okay, what it is showing, not that, oh, the color doesn't look good, this text is not proper, those are not the things people should look at. They should look at what is that you're trying to say. Okay. So Indians make them, okay, avoid distorting what data has to say. Okay. There is a famous saying which says that if you torture the data, it will accept whatever you have to say. When police catches a thief, right, and if they start torturing, they'll accept everything, right? The same thing, if you torture the data, right, it will accept everything. So you should not torture the data. Let data tell its own story. You should not manipulate data. You should not manipulate, you should not hide. Sometimes you hide something, you only show half of the thing, you don't show half of the thing, other half. Okay? Present many numbers in a small space. Okay? Make large data sets coherent. Encourage AI to compare different pieces of data. Okay, sometimes it happens what they don't want to show, they'll make it very small. What they want to show, they'll make it very big. Okay, so that those things should not be done. Okay, now we have different types of graph. One is called time series graph. Time series graph is something that you show over a period of time. Now, the previous example which we did, it is the example of time series graph. Year is 14, but we are seeing from Jan to December, entire year. Yeah. So it is showing you by time. If I've taken this top 10 and present in decreasing order, even though Ferguson Grand Jury is in December or November end, I could have presented the beginning. If I wanted to show you the which is most talked about, but here I'm not doing that. Okay, when I say I, it's the graph. Okay, it is showing you on basis of time how things are happening. This is an example of time series graph. Then we have ranking. So if I had used highest, second highest, third highest, fourth highest, that would have been a ranking graph, right? You talk about this GDP growth or things like that. They would create a ranking graph. Highest country with the highest GDP growth, then second, so on. Part two whole kind of graph is where you want to show percentage contribution, pie chart basically. Pie chart is to show you that, okay, if you consider entire thing as 100%, then this segment is contributing 33%. So part is 33% to the whole, right? That's another type of graph. Then deviation. Deviation is where you have planned and it is not performing to plan. So sometimes what you'll do is you will create, okay, these are the topics I'm going to cover every day. Are you sure? Someday you'll cover more than what you have planned, someday you'll cover less. That is a deviation graph. So you had a plan and then actually how it actually performed. So, in business, they would create these first, they'll have actual versus budget. So budget is the baseline. They'll budget baseline. Actually, sometimes you'll exceed budget, sometimes you'll be under budget. So you will show with respect to budget how you're performing, right? So in cricket matches, they'll show you, right? Required rate is 5, straight line. Sometimes you'll hit more than 5, sometimes you'll go below 5, right? That is a deviation graph. Then we talk about frequency distribution. What is frequency distribution? So here you're talking about distribution of values. Okay. So for example, you have a class of 100 students. Okay. And after 10th class marks, you want to show them how many students have scored how much, right? So let's say you have 100 students. Okay. Let's say, okay, you create a groups. Okay. You can create a group between 0 to 10. Okay. 0 to 10 marks. Okay. 10 to 20. Okay. 20 to 30. Okay. So on up to 90 to 100. Okay. Or you can create maybe 0 to 30 or 0 to 25. $25 to 50, 50 to 75, 75 to 100. Okay. Now you can choose. You can create 0 to 5, 5 to 10, 10 to 15. Up to you. Few things have to keep in mind. One, the gap, the range that you see, 0 to 10. What is the range? 10. Difference is 10. 10 to 20. What is the range? 10. The gap should remain same. The range, we'll talk about statistics called range. Range should remain same. I cannot say 0 to 30 and 30 to 40, 40 to 80, 80 to 90, 90 to 95. No, it has to have same. When you're drawing frequency distribution, yes, sometimes we do talk about it, right? We club 0 to 30, but here when you're drawing a frequency distribution, it has to be the gap, okay, the range has to be same. In second case, range is 25. First case, range is 10. I can create 0 to 5 also. 0 to 5, 5 to 10, 10 to 15, range is 5. So you can choose your own range. Yes. No, if you take 20, everything has to be 20. 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. So that's when you'll get the exact information. If you don't group them properly, now let's say if I take 0 to 30, or 0 to 40, 40. So, no, I'm taking 10 difference only, no. So you're saying why like that? No. I'm just saying if I'm not taking 10, if I don't take 10, okay, say 0 to 40 is 40, 40 to 60 is 60, 60 to 70 I take, and then I take 70 to 100. Okay, as per my wish. Now let's say each of these have 25 students. So when you plot a graph, you'll see bars, all bars are 25, 25, 25. Okay, you are not going to make any sense out of it. Okay, so when you put 0 to 10, let's say here 0 to 5, you will see 25, right? So we will have probably, let's say, only 10 students. Okay, you have only 10 students. Then 20 to 40, you might have 30 students. Okay, 50 to 75, so you'll have maybe around 35. And then you'll have 25. So this tells you that, the very few students with low marks and very high student, middle have, most of the students are in middle and higher students are in the high side. So again, when we get into plotting, we'll discuss, but this gives you some meaning. This tells you, when you look at this number, if you plot bar graph, simple bar graph, okay, frequency distribution is drawn as a bar graph. But the only thing is the range matters. In bar graph, you only have apple, banana, like one specific index. Here, you'll have range of values. So I'm saying between 0 to 25 marks, there are 10 students. 25 to 50, there are 30 students. So 50 to 75, there are 35 students. When you plot the bar, you'll see that first one is a small bar. Next one is a big one. And again, bigger, not small, not big. So you'll see that there are very few students who have got less number of marks, right? Now, if you have other way around, let's say here you have 40, okay, 20 maybe, okay, and you have 5. This means that here most students have failed. Most students have failed. Okay, let's say passing mark is 40, definitely more than 40 have failed here. So you can, when you have the base same, you can compare. So if I give you base same, like 7, 7, 7, you can compare, numerator if it is 4 and 5, 5 is bigger than 4. But if I give you 2 by 7 and 9 by 14, it will be difficult for you to find out, right? I have to calculate. So that's why frequency distribution is drawn with keeping same range. You can keep 0 to 5, 0 to 10. Okay, so you look at lowest value and highest value. Based on that, you create your range. One more thing is, again, this is must, okay? For frequency distribution, you need to have same range. One more thing you have to keep in mind here is, when you are drawing this frequency distribution, you should not have more than 10 to 12 or 13 kind of bars. Okay? Because too many bars, very difficult to analyze, and too few bars, you have not got enough data to visualize. So typically 8 to 12, around 10 should be good. In this case, so 0 to 25 is giving us only 4 bars. Okay, so we have to increase the range. 0 to 5 will give us how many bars? 0 to 5, 5 to 10, so on, 5 range. How many bars will I get? 40,000 plus? You will get 20 bars. Isn't it? You will get 20, 0 to 5, 5, 5, 5, 5, 5, 5 into 20, 100. So you'll get 20 bars. So 0 to 10 is good range in this case. You get around 10 bars. Okay, so this is called frequency distribution. In frequency distribution, you arrange on some axis, okay, and on y-axis you talk about number of people in that range, number of people, number of whatever. So on y-axis is always number. On x-axis is always range. So range is on x-axis and number on y-axis, and all these are all your which graph? Bar graph. Okay, so frequency distribution talks about bar graph. Okay, and it shows the frequency of the distribution of values. Then you have correlation. What is correlation? Correlation is to show the impact of one member on another member. Impact of temperature versus sales of ice cream. Okay, so you will have on one axis, it is generally represented as XY axis. Okay, so I want to see the relationship between temperature and the sales. If temperature is 25, how much sales have you made? Temperature is 30, how much sales did you make? Temperature is 40, how much sales did you make? So we have XY plane. Generally in this case, thing which is constant, okay, we put on x-axis. Something that changes. Generally, mathematics equation, right? Y equal to something x, right? Y equal to mx plus c. So your x is something which is known, and y is something that you want to find, calculate. That's why we said y equal to mx plus c. So, okay, it's not mandatory, but this is a general. You can say x equal to my plus c also, right? But generally we don't say, we say y equal to, right? So it's about notation. So things which are easy to find, we put it on x-axis. Things which are difficult to put, we'll put it on y-axis. So in this case, correlation, you will go to ice cream shop and you ask that guy, okay, the temperature you can find from Google. What was temperature yesterday, temperature day before, you can find. So temperature is easy to find, sales is difficult to find. Okay, so we want to find sales. So when you draw a correlation graph will look something like this. Okay, x and y. Okay, on x-axis we put temperature, 0 degree, 5 degree, 10 degree, 15, 20, 25, 30, 35, 40, right? And then on this, you will put rupees, right? This is your degree Celsius. So, if you yesterday, what was the sale? Sale was 50,000 rupees and temperature was 27. So, 25 plus 27. This is your x-axis and this is your 15,000. So, let's say you put 5,000, 10,000, 15,000, okay, so 15,000 here. So this is your point, right? So you will draw a point, okay, you draw a point only, we don't draw a line. This is just to show. So you'll say, this is the point. Second day, temperature also increased, sales also increased. Third day, temperature decreased and sales also decreased. Temperature decreased. Temperature decrease means here. Temperature is lower, sales lower. Okay. So here we're not about days, we're talking about temperature and sales. So temperature is lower, sales is lower. Temperature increases. So when you see this, this is called correlation. So what are we correlating? We are correlating the sales that can happen based on the change in temperature. What is the change in sales when there is a change in temperature? So when you see something like this, okay, when you see something like this, what do you see? You see there is an increasing trend. As temperature increases, sales also increases, right? So this is what you get from correlation. And when we get into correlation, we'll talk about other conditions also. So correlation is to show relationship between two values. Later, when we get into machine learning, we'll see that it can extend beyond third, fourth, fifth, sixth dimensions. But going beyond 2 dimensions, we can't plot. But you can have 3 dimensions also. How the relationship between 3 variables. Okay. So in 3 variable, here in 2 dimension, you have a line which shows between x and y. In 3 dimension, it will be a plane which will show the dimension between x, y, z. Okay. We'll talk about it when we go there. So now you see, correlation is telling us the relationship between x and y, temperature versus sales, number of hours you study versus marks you obtain. Okay. So that's called correlation plot. You're comparing 2 variables. Okay. Okay. And yes, and what we just drew is called scatter plot. What we just now drew is called scatter plot. Scatter plot will have points, and one point will represent value on x and y. So if you see here, this has a value on x and value on y, isn't it? So this represents 2 points, value on x and value on y. So that's called correlation plot, okay, or your scatter plot. Then we'll talk about nominal comparison. Okay, nominal comparison is just to compare the nominal values. That means specific values. Okay, let's say we conduct a test. So what is the marks obtained by 8 of you? You can simply plot a bar graph. That's called nominal comparison. Okay, or nominal comparison, or bar graph. You can draw a bar graph. So using nominal comparison. Okay, we are not doing any calculation. Simply taking the marks and plotting. But condition here is that denominator has to be same. I cannot take your marks out of 10 and her marks out of 50. So denominator has to be same. If it is not same, then you make it same. Right? If you get out of 10, then probably multiply with 5. Then you'll be able to compare the values. Nominal comparison. Geography is when you put a map. So you want to show rainfall in India. So create an India map and you will show the cities and the amount of rainfall in each city. So these are different types of graph we are going to learn as you go along. Okay. Time series, ranking, part 2 whole, deviation, frequency distribution, correlation, nominal, and geographic. We are going to use matplotlib, pandas, seaborn. Okay, we are not going to use ggplot, but you can practice that. I'll give you code. I'll give you source. For pandas, you have to use NumPy only. You can't go to pandas without using NumPy. So we'll do NumPy for sure. But pandas is to actual uses. So NumPy we learn so that we can learn pandas. So what is important for us is pandas. So pandas, seaborn, and matplotlib. You can similarly have ggplot and plotlib. You can practice that. Okay, why vision is important for faster decision making. Okay, you can read these things. Okay. Okay, so this is a chart, okay, of a company spending or industry spending amount for their marketing. So you see here on August 2009, they spent only 1.1% of revenue on marketing. Okay, in August 10, they put 9.2. August 2011, they put 6.7% in marketing. So this shows you how the industry is changing the amount that is being spent on marketing. Okay, so we'll stop here. This example we'll take tomorrow and we'll do. Okay, so we'll talk about data visualization usage. We'll see the usage. We'll take this example and we'll do it. Okay, so meanwhile, please practice all those things. Let's close Python. Okay, any questions you have, please let me know tomorrow.
Yes, sir.
Okay,
Tomorrow at 10 o'clock is the class.
tomorrow is Friday, right? 10 o'clock, yes.
Yes, sir. Okay, sir.
Yeah.
Thank you.
Take care then, everyone.
Yes, sir. Bye, sir.
Bye.